All right. On your formative main page, you should be looking at Lesson 15, Part 2, Notes on Multiplying Matrices with Properties and Application. All right, you guys ready to go? Yeah? Everybody good? All right. Okay, let's just jump right in. We're going to go to the Show Your Work section of our paper. And oh, you don't have it yet? Okay, hold on. All right, so everybody should hop in. All right. So here's what we're going to do for this first question / notes. What I'd like to do is I'd like you to take this section and I want you to just break it into 2 parts, left and right. Oh, like that. Okay. All right, now we are going to use the matrices over on the left, and you can see they're 2 by 2 matrices, right? So we know that we can multiply these because the columns in A and B, they all line up. We're going to have 2 by 2 answers, so we're good there. So what I want to do is, on the left, I want to find the product AB, and on the right, I want to find the product BA. And so we're going to do 1 level of work in here for each one, like this, where you're going to write in your multiplication sums, right? Like we were doing in our practice. Again, same thing over here. Write in our multiplication sums over here. Probably do that one a little bit better. And then we will come up with our answers for A, B, and BA here. Everybody understand what I want you to do? Yeah. All right. Then do. All right. Let's take a look up here. Focus with me. All right. So check your work. Did you come up with the correct answer matrices? All right, question. The other day we talked about different types of matrices, like I told you about, like row matrices and column matrices and zero matrices. I also told you about equal matrices. What was the deal with equal matrices? No, not same dimensions. No, good try. What's the deal with equal matrices? No, doesn't know. Don't overthink it. Equal. They're exactly the same. Every element is exactly the same in the corresponding positions. Question: are these 2 products equal? No, these are not equal. Now, what's special about the multiplication problems that we just did? I heard it. Who said it? What did we do with the matrices? We did what with the matrix? First it was A times B, and then it was what? B times, like 3 times 5 is what? And 5 times 3 is what? And that works in multiplication, doesn't it? And we call that the what? No. Good try. It's a property. Which property is it? Come on, you got it. Begins with a C. Commutative property. 2 plus 3 is 5. 3 plus 2 is 5. Okay, all right, okay. All right. Let's take a note. Here we go. You ready? Okay. Matrix AB, product AB is not equal to product BA, which means that there is no commutative property in matrix multiplication. So when it comes to multiplying matrices, commutative property does not apply. So we've been used to the fact that, like I said, 3 times 5 is 15, 5 times 3 is 15. The order in multiplication doesn't matter because commutative property applies. But when we're multiplying matrices, the commutative property does not apply. They are not equal. Okay? All right, so that's an important one to keep in mind. That's going to revisit in a little bit. Let's talk about some other properties that do exist for matrix multiplication. So we can have associative property. So watch this. We could go matrix A times matrix B times matrix C, and we could do A times B first and then multiply by C. Or we could have matrix A times matrix B times matrix C. We could do B times C first and then multiply by A. That does work, but because you'll notice the order of in which we're multiplying the matrices does not change. So the grouping of them is okay. We just can't change the order. All right. Now, we can also do this with our scalar multiplication. So watch this. Let's say we had, so K is going to be our constant, our scalar, and we wanted to multiply that by a product AB. Okay? That is the same thing as doing K times A and then multiplying by B, or K times B and then multiplying by A. So wherever we put the scalar multiplication, you guys remember that from the first lesson, right? Where you had the matrix, and then you had like a 7 out front or a -2 out front. You multiplied all the elements by that -2. Okay? We can multiply the matrices and then scale it. We can scale one of the matrices and then multiply it, or we can scale the other matrix and then multiply it. That all works. Okay, watch this one. Left distributive property. Left distributive property? That sounds weird. Okay. We could have matrix C times matrix A plus matrix B. Okay, and what that would look like from a distribution standpoint would be C times A plus C times B. This is our standard distribution. So we could have a matrix and then two other matrices being added together, and we could distribute the C matrix to both of those, especially if we couldn't add A and B together because they didn't have the same dimensions. We could still do matrix multiplication with left distribution. Now look at right distribution. Like, wow, that's weird. Right distribution? Well, yeah, sometimes, we have that number on the right side. It still means multiplication, right? And it could still process the same way. It'd be like saying like 2 times n, 2n, or n times 2, n2. It works. It's just a little funky. But here's where it's important. Watch this. This has to be AC plus BC. The C's got to come second. See that? Because when it's on the right, the order in which we multiply these matrices, because commutative property doesn't apply, is very important. All that to be said, we're really not going to use a ton of these properties, but I wanted you to be aware of them. So, okay? It's probably okay as long as you remember that, distributed or that commutative property does not apply. As long as you remember that one, that's the most important one. Okay? The other ones, we're not really going to get too deep into them because we have other things to do. So, all right. Let's put a little application into practice here. Actually, this really is at the heart of our computer science analogy, because what we want to do is we want to be able to take different lists of items and then put them together in different ways. So at its base level, here we have two teachers using 3 different types of supplies, and then we have 3 different types of supplies at their respective costs. And we could fill this information up into a table, and then we could ask all kinds of questions about it. Like, we're going to ask the question, how much did Mr. Smith spend and how much did Mrs. Wills spend? But we could ask, how much did Mrs. Wills spend on markers and staples versus how much did Mr. Smith spend on paper and markers? There's a lot of questions that can be asked from this data being just written down one time and then compiled. Okay? All right, so here's what we're going to do. You read through the problem right here. It's everything I just said to you. Is straightforward like that, right? And then we're going to use matrix multiplication to calculate the total cost of supplies for each teacher and show that in a matrix for our answer. Then we're going to answer the questions below. So the work part is us doing the matrix multiplication, okay? The work part is us doing the matrix multiplication. So let's set up a matrix for the types of items that the teachers used. So what do you think the dimensions of this matrix are going to be here? 2 by 3. Very good, right? Anthony. So loud. So distracting. Okay. So we're just basically pulling the data out from the context, because now we know what each of those numbers represent, right? So basically we've given those numbers a meaning. And now we're going to pull some more data, right? Because every time they use some paper, a ream of paper, it's going to cost $15. So 6 reams of paper is going to be 6 times $15, right? Like, that's just plain old logic, right? But we're going to do all of that math at one time by using matrix multiplication. Instead of doing all these individual math problems, we're going to combine it all together. So then let's take this one, which is going to be just these numbers here. I guess the question is can we multiply those matrices? Right? What's the dimensions of the first one? 2 by 3. What's the dimensions of the second one? 3 by 1. Okay, check. What's our answer matrix going to be? It's going to be a 2 by 1. 2 by 1. 2 by 1. Wait a minute. That's going to be 2 by 1. Mr. Smith, row. Miss Wills, row. We're combining these together, right? We're multiplying them. So it's going to be the cost, total cost of what Mr. Smith spent and what Miss Wills spent. Okay, cool. Right on. All right. Well, let's do a little work in here. Actually, I'm gonna before I write my answer matrix, let's get a little space in here. And what we're gonna need in here is something in here and something in here. Okay. Put this down for right now. And in the end, we're going to end up with a 2 by 1. Okay, go ahead.
Okay.
Just like that. Just like that. Okay, I'm going to give you a step. If you're moving in the right direction, you should have gotten here.
Yes! I got it.
All right, you should have ended up here, right? Okay, now I want you to think about something for just a second, right? I said that there were a lot of questions that could be answered from this. One of the benefits of writing out this work here is this lets you drill down a little bit further into the questions. Because if you think about what this work represents, it represents Mr. Smith's cost of paper usage and Mr. Smith's cost of marker usage and Mr. Smith's cost of staple usage. And then the same thing for Mrs. Wills here. So we can total all those numbers up to get the complete amount that they spent. Or we could look back at the work and we could answer more detailed questions. Like, let me ask you this. How much more money did Mrs. Wills spend on paper than Mr. Smith? See? You can read the data now. See how that works? Right? See, now we can ask so many more questions by just doing this one application and presenting all of that data. Now the questions can be asked in a lot of different ways, which provides more important study for the things that we need to know. And that's why this is a benefit to us. Because again, we can ask these questions of a computer because we can write programs and say, in cell such and such, like, for example, A11 or A12, like that, we could ask that question and come up with a calculated answer without us even having to do it, which is the benefit. Okay, all right. And of course, listen, when we're doing the math here, it's fine if you leave the zeros off, if you leave the dollar signs off, because we're just crunching numbers. But when you write your answer in context, of course, you have to put the dollar signs in, right? So everybody should now have 2 points. Okay? Okay, everybody good on formative? 2 points? Yes? You got your answers in? Okay. All right, fantastic. Alrighty. So, students at Oak Hill High School are selling bags of popcorn for $10 each, a tub of cookie dough for $12 each, a fruit basket for $16 each to raise money for their class rally budgets. The given table shows what they sold in terms of the amounts of items. Oh, sorry. Well, so we have some information given to us, right? And then other parts of the information is given in the problem, right? And so we've got to come up with some way to calculate this. Now, it says if the students earn a 15% profit on each item they sell, use matrix multiplication to calculate the amount of money each class earns for their rally budgets and give that answer in a matrix, and then show work to support your answer. All right, well, we'll come back to answer the questions in a minute. Let's take some room to work here. Let's make this a little bit cleaner in terms of our matrix. Let's just take this data and get it into a matrix. So this is going to be a 4x3, right? So we'll go 60, 75, 40, and 91. And just so we know, we'll get freshmen, sophomore, juniors, and seniors like that. So then the next column is going to be 84, 58, 63, 47. So now it's like entering data, right? 45, 28, 18, and 32. All right, now we want to come up with some matrix multiplication here. And we want to calculate, in the end, we want to know how much money did they make, right? So do they make $10 on every bag of popcorn they sell? They do. They make a 15% profit. They don't make $10. They collect a bunch of money. They collect $10, but that's not how much they make. How much do they make, like, for their rally budget? Because it costs them something to buy the popcorn, right? Profit. How much? $1.50 would be right. Yeah. Okay. So our bags of popcorn, they make $1.50 on. Okay, so that's $1.50 for their bags of popcorn. 15% of the costs for each one. So how much do they make on the cookie dough? Okay, so 15% of what? Okay, so how much is that? $1.80. Okay, good. All right, and what is their profit on the fruit baskets? How much? $2.40. Okay. All right, so now if we know how many of each item they sell and we know how much profit they make, then we can determine all of our totals, right?
Yeah.
And we can do that with one swoop through some matrix multiplication, as long as we can multiply these. Can we multiply them?
Yeah.
Okay, so we got a 4 by 3 and a 3 by 1. So checks. And it's going to be a 4 by 1. Okay, all right. Well, let's make a big 4 by 1 for some work. And then let's make a little 4 by 1 for our answer. And let's see what you come up with for those. Go ahead.
Put your seatbelts on. That was no.
Okay, so I'll give you a checkpoint. If you're moving in the right direction, you should have come up with this here for your row 1 times column 1. Some answers up for you to take a look at. Here's what you should have come up with here. And again, the other thing that's nice about this is by taking the time to organize your work like this, it allows you to easily go back and check if you'd made a mistake. Like, let's say I asked you, what did the freshmen make? What did the sophomores make? What did the juniors make? What did the seniors make? And you were typing those numbers in, and one of them was wrong. Well, now you don't have to go back and redo the whole problem. All you have to do is go back to that row and check those answers. And so what's nice about this is that it keeps everything neat and organized, which is the same thing with our box multiplication we're going to see moving forward too. All right. And then it's a question of just answering from the data. Is everybody good? Got it figured out? Yeah, I can leave it up. Okay. All right. Okay, so then I'm going to start working on launching your practice assignment, okay? And then that one will be due when I see you guys on Thursday, okay? You'll have the remainder of the period to work on that.